In this lesson, we are going to determine a differential equation from a general solution. Join me as we go through a series of examples step by step. Hello and welcome to my channel. I'm Mensa Augustine. Please kindly like my videos, subscribe to my channel, hit the notification bell to get notified when I upload new videos, comment and share for us to build the mathematics community. The first question that we have is very simple. We are to show that x squared plus y squared equals c is a solution to the differential equation y times y prime plus x equals 0. Now, let us do this simple thing, but let us remember that y prime is the same as dy on the x, because here we are going to differentiate implicitly with respect to x, and y prime prime equals the squared y on the x squared. Now, differentiating x squared with respect to x gives 2x. And differentiating y squared with respect to x gives 2y dy dx. But here we are going to write y prime. If we differentiate c, it's a constant, so we get 0. Now, if we divide through by 2, we get x plus y prime equals 0. And that is all that we are looking for. So it means that x squared plus y squared equals c is a solution to the differential equation x plus y prime equals 0. Now let's take our another example. We are to show that y equals cx plus c power 4 is a solution to the differential equation y equals xs prime plus y prime all power 4. Now, we do simple differentiation. So here we take y prime equals c, because if we differentiate cx, we are going to get c. And if we differentiate c to the power 4, since c is a constant, we get 0. So we have y prime equals c. Now, wherever we see c in the original equation, let's put y prime there. So we're going to have x times c, that gives x times y prime plus c to the power 4, and c is y prime, so we write y prime to the power 4. So this simply tells us that y equals cx plus c power 4 is a solution to the differential equation y equals xy prime plus y prime power 4. Please kindly like, subscribe, follow and comment for us to build the mathematics community. Our next question is to show that y equals c1x plus c2 e to the power x is a solution to the differential equation into bracket x minus 1 bracket close y prime prime minus x times y prime plus y equals 0. Now we take y prime equals what? If we differentiate c1x with respect to s, we get c1, since c1 is a constant. Now, if we differentiate e to the power x, we get the same e to the power x times c2 gives plus c2 e to the power x. Okay, so here we will take the second derivative since we have two arbitrary constants. So y prime prime equals, if we differentiate c1 with respect to s, we get 0. If we differentiate e to the power x, we get the same e to the power x times c2 gives c2 e to the power x. Okay, so now we have 3 equations to solve them simultaneously, and our aim is to get into bracket x minus 1 times y prime prime minus xy prime plus y equals 0. So let us subtract equation 3 from 2. Here we take c2 e to the power x from c2 e to the power x and take y prime prime from y prime. Okay, so if we take this from that, we get 0 and it will remain c1 on the right hand side. Let's name this equation 4. That's very simple as that. Taking c2 e to the power x from c2 e to the power x in equation 1 can also help us. So we take equation 3 from 1. So we take c2 e to the power x from c2 e to the power x and we get 0. And we take y prime prime from y. So we have y minus y prime prime equals c1 times x. That is c2 e to the power x minus c2 e to the power x, and it will remain c1x. So c1 is what we've had in equation 4. So we take y minus y prime prime equals y prime minus y prime prime times x, and then expand this. So we have y minus y prime prime equals xy prime minus xy prime prime. Now, let's group. This gives y minus y prime prime plus xy prime prime minus xy prime equals 0. Now we can factorize y prime prime out. So we have y prime into x minus 1. That is, if you factorize y prime from x, you get y prime, and then x inside. And if you factorize y prime from negative y prime, you get negative 1 inside. So this gives minus xy prime plus y equals 0. So this shows that y equals c1x plus c2 e to the power s is a solution to the differential equation y prime into x minus 1 minus xy prime plus y equals 0. Now let's see the next question. I hope you are enjoying the lesson. Please kindly like, share, follow, and comment. The next one is to show that x cubed minus 3x squared y equals c is a solution to the differential equation into bracket x minus 2y dx minus x dy equals 0. Now we move straight to our implicit differentiation. If we differentiate x cubed with respect to s, we get 3x squared. Now for 3x squared y, we use product rule. So we take 3x squared and differentiate, we get 6x times y. That gives minus 6xy. If we differentiate y, we get y prime. And then we multiply it by minus 3x squared equals, if we differentiate c, you get 0. Wow. So here we can divide through by 3 to get x squared minus 6xy minus x squared y prime equals 0. Then if we if we divide through by x, we could have divided through by 3x. So if we divide through by x, we have x minus 2y minus xy prime equals 0. Now we are good to go. Very, very simple as that. Now we said that y prime is the same as dy dx. Since we are differentiating y implicitly with respect to x, so here we take x minus 2y minus x dy dx. Then we multiply through by dx. This gives x minus 2y times dx minus x dy equals 0. So this shows that x cubed minus 3x squared y equals c is a solution to the differential equation into bracket x minus 2y dy dx minus x dy equals 0. Please kindly like, share, comment, and follow us to build the mathematics community.